All right, everyone, get ready because today we are taking a deep dive into AI and 3D modeling.
Sounds fun.
Yeah, you sent this research paper over, and it's really interesting.
Oh, wait.
Yeah, it's called LLaMA-Mesh, and it sounds like something straight out of science fiction.
Oh, wow.
Like, imagine just telling a computer what you want to create, and it just makes a 3D model of it
Really?
right before your eyes. No more messing around with all that crazy software.
That's incredible. So where did you find this?
The source is a paper straight from the brilliant minds at Tsinghua University and NVIDIA.
Wow, some pretty big names.
Yeah, for sure.
So I have to ask, what's so exciting about this research?
Well, it's really cool because it combines two super powerful technologies, and they don't normally go together.
Uh-huh.
So we're talking large language models, like those chatbots that everyone's using these days, and the world of 3D mesh generation.
Right.
And, I've always been a bit intimidated by 3D modeling software. I mean,
Me too.
give me a pencil and paper any day, but this LLaMA-Mesh, it almost sounds too easy.
So how does it actually work?
Right.
Yeah.
So basically, LLaMA-Mesh uses those powerful large language models, those LLMs we hear so much about, to understand and generate those 3D models.
Yeah.
But the real genius is how they do it.
Oh.
They represent 3D meshes as just plain text.
Okay.
Using that OBJ file format, it's like translating a complex 3D object into a language the LLM can understand.
So the AI is reading a text description of the object instead of, like, lines and shapes.
Exactly.
Wow, that's wild.
Yeah, it's pretty crazy. It's a game changer.
So now the LLM can work with these 3D models using the same techniques that it uses for any other text.
Right, and that is amazing.
Yeah.
Now, there was this part in the paper that really caught my eye. It's about quantizing vertex coordinates.
Okay.
And that sounds super techy, but I think it's really important.
Yeah, it is technical, but it's really crucial to how this whole thing works.
Can you break that down a little bit?
Yeah, so those vertex coordinates, they're basically the points in space that define a 3D object's shape.
Okay. And to make this data easier for the LLM to digest, the researchers quantized these coordinates. They basically grouped them into a specific number of bins.
So it's like simplifying the data, but without losing all the details, kind of like compressing a large image file.
Yeah, that's a great analogy.
Okay, cool.
And this is where it gets really interesting.
Okay.
They're not just making it easier for the AI to process the information, but they're also tapping into the spatial knowledge that these LLMs already have.
Wait, so the AI is learning about 3D structures just from reading text? How does that even happen?
So think about it. When we describe things, we use spatial relationships like above, below, next to.
Right.
And these LLMs, they've picked up on those patterns by processing tons and tons of text and code.
That's amazing. So they're building on what's already there.
Yeah. And LLaMA-Mesh uses that existing knowledge to generate and manipulate 3D models with crazy accuracy.
So they're not starting from scratch with the AI spatial understanding. They're basically like building on top of it. That's awesome.
Exactly. Okay, but let's get to what everyone wants to know. What can this thing actually do?
Right.
The paper mentions some pretty impressive examples.
Yeah. So for example, imagine you're designing a video game and you need a 3D model of, say, a sword.
Uh-huh.
You could just type a sword and LLaMA-Mesh would generate that model.
Whoa, hold on. Just from that text, it would make a sword.
With a handle, blade, even a guard, all from that simple text prompt.
Wow, that is what I'm talking about. The paper doesn't stop there, though, does it?
No, the researchers also showed that it can understand and interpret existing 3D models too.
No way.
Yeah.
So it's not just building them, but it's like understanding them too.
Yeah, it can answer questions about the model's features, what it represents, even hold a conversation about its design.
That is so cool.
It's not just building, it's understanding.
Right.
And a big part of that is how they train the data.
Okay.
They use this combination of text 3D pairs and these mock conversations about the 3D objects.
Okay, so it's like giving the AI a crash course in 3D design, but through dialogue.
Yeah, exactly.
I love that. And then they mentioned using this Objaverse dataset. What is that all about?
So Objaverse is a huge collection of 3D objects. You name it. Furniture, tools, animals, vehicles.
Wow.
They used it to train LLaMA-Mesh, exposing it to all these different shapes and structures. It's like sending the AI to a 3D design masterclass.
That's amazing. So it's had all this training and experience, but how does it compare to all those other 3D modeling programs out there? Is it just a toy, or can it actually compete with the big players?
Okay, so this is where it gets really interesting.
Okay.
Even with its unique approach, LLaMA-Mesh is creating 3D models that are comparable in quality to those fancy models like Mesh XL and Unique 3D, the ones that are specifically designed for this.
Wait, so you're saying it's just as good as those industry standard tools?
Pretty much. And
Wow.
remember how we talked about quantizing those vertex coordinates?
Yeah.
Well, that clever trick makes LLaMA-Mesh so much more efficient to train than something like Mesh XL.
So you're telling me it's faster, more efficient, and just as good?
That's right.
This sounds almost too good to be true. What's the catch?
Well, you're right. Every new technology has its limitations.
Right.
And LLaMA-Mesh is no exception.
Okay, so what are the limitations of this technology?
Well, first, remember that quantization we talked about?
Mm-hmm.
While it's super efficient, it does mean that some of the finer details get lost in the final 3D model.
Right.
So it's a trade-off.
So you're sacrificing a little bit of detail to make the process easier for the AI.
Exactly.
Okay, that makes sense. Are there any other limitations?
Yeah, another big one is the LLM's context length. It's basically how much information it can process at once.
Okay.
And right now, that limits how complex and how big these 3D models can actually be.
So it's like the AI has a working memory limit.
Yeah, exactly. The bigger the memory, the more complex the designs can be.
Right.
So you can't just describe your dream mansion with every little detail and expect LLaMA-Mesh to build it in 3D. Not yet, at least.
Okay, well, I'll keep dreaming.
But who knows what the future holds. Things are moving so fast with LLMs. Breakthroughs in how we train and how we build them are pushing those context lengths further and further.
So maybe someday.
Exactly.
So it's getting a bigger mental workspace to handle those more complex designs. That's really exciting.
Yeah.
Now, you mentioned earlier that the researchers saw a little dip in LLaMA-Mesh's language abilities after they fine-tuned it for that 3D generation.
Oh, yeah.
What happened there?
It seems like all that focus on 3D data during the fine-tuning process might have caused it to lose a little bit of its general language knowledge.
It had to specialize.
Yeah, becoming a 3D expert,
Yeah.
but maybe at the cost of some of those broader language skills.
So there's a balance to strike. You want it to excel at its new task, but you don't want it to lose all its other skills.
Right.
Like you said, you don't want it to be a one-trick pony.
Exactly. And the researchers know that. They're exploring different ways to address that, maybe by using a more balanced mix of 3D and general language data during training.
Okay, so like giving the AI a well-rounded education.
Yes, precisely.
Cool, I like it.
It's important to remember, though, that even the training data itself has its limits.
Uh-huh.
They mostly use the Objectverse dataset, which is great. It's big.
Right.
But it might not cover every single 3D object and design in the real world.
So is there a chance that LLaMA-Mesh might not know what to do if it encounters something totally new, something that wasn't in its training data?
It is a possibility.
Okay.
But remember, AI is all about learning.
Right.
As we get bigger and more diverse 3D datasets, LLaMA-Mesh can keep learning and growing, just like us.
Right, so it's like giving it more experiences to draw from and become more well-rounded.
Exactly.
Even with these limitations, this is really remarkable.
Yeah, it is.
It's a huge step forward in merging language and 3D design.
Right.
And it opens up so many doors for collaboration and creativity.
Absolutely. It's amazing what AI can do.
This research is really pushing the boundaries of what we thought was possible.
Yeah.
And it just shows how much potential AI has to change how we design, create, and interact with the world.
For sure. It really makes you think about the future.
It does, and we've covered a lot today, from how LLaMA-Mesh works to its potential. And I want to leave you with a question.
Yep.
If you could describe anything you wanted and have a computer create it, what would you create? And what challenges and opportunities do you think would come from that?
That's a great question.
It's something to think about. LLaMA-Mesh is really pushing the boundaries of what we thought was possible, and it's a glimpse into a future where creation is only limited by our imagination.
It really is a game changer.
But we're not done yet. Stick with us, because we'll be back in a moment to uncover even more about this research.
I can't wait.
All right, we'll be right back after a short break.
Welcome back. We've only just scratched the surface of what makes LLaMA-Mesh so fascinating.
I know, right?
It's like we've been given this magic wand for 3D design, but even magic wands have rules.
Okay, I like where this is going. What are the rules for this 3D magic to work?
The researchers were really careful about how they trained LLaMA-Mesh.
Yeah.
It wasn't just throwing a bunch of 3D models and text descriptions at it. They really structured that training data to teach the AI very specific skills.
So it's not just about how much data they use, but the quality of the data and how it's presented?
Exactly. It's all about quality over quantity in this case.
That makes a lot of sense.
And all those text 3D pairs and those simulated dialogues that we talk about,
Oh.
they designed those with very specific goals in mind.
Like what kind of spills did they focus on?
So one type of training data was all about mesh understanding.
Okay.
So they would give the LLM a 3D model, in that OBJ format, and then ask it questions
Like what?
like, what is this object, or describe its features.
So it's learning to recognize and interpret the models just from the text.
Exactly, like teaching it to read blueprints.
That's really cool.
Right. And then they had mesh generation training,
Okay.
where they gave the LLM a text prompt, like create a 3D model of a car,
Mm-hmm.
and they had to create the OBJ code.
So it's learning to translate human language into the language of 3D design.
Right. And to make things even more interesting, they included data that mimicked back and forth conversations about 3D modeling.
So they're teaching it to collaborate.
Precisely.
Yep.
And all this careful data preparation is what allows LLaMA-Mesh to do these incredible things. It really shows how important it is to think about how you train these AI models.
That's fascinating. It sounds like they had to be really creative to train LLaMA-Mesh.
Oh, yeah.
To get it to this level. And they also mention using something called augmentation techniques.
Yes.
Both rule-based and LM-based.
Yes.
To really boost that training data. Can you tell us more about that?
So imagine you have a 3D model of a chair, and the description just says a chair with 4 legs. Rule-based augmentation would be like making small changes to that chair,
Okay.
like adding armrests or changing the back and then updating that text description to match.
So you're getting more variations from just one example.
Exactly.
That's really clever.
And then LLM-based augmentation takes it a step further. They actually use a different LLM to generate completely new text prompts and 3D models based on that chair example.
Whoa. So it's like AI is brainstorming 3D designs.
Yeah, that's a great way to put it. And these techniques help them create a huge and varied training data set.
That's amazing. And something that really stood out to me in the paper was how concerned they were about LLaMA-Mesh keeping its language abilities.
Oh, yeah.
Why is that so important?
That's a really good point. It shows they were thinking about the big picture.
Oh,
They didn't just want it to be a one-trick pony, just a 3D modeling machine.
right.
They wanted it to still be good at understanding and generating human language.
It's like they wanted a tool that could actually collaborate with humans on these creative projects, right?
Exactly.
Understanding our ideas, answering our questions, maybe even suggesting designs.
Yeah, it had to be able to speak our language.
Yeah, it makes sense. So how did they ensure that LLaMA-Mesh didn't lose those language skills while it was learning all this 3D stuff?
They were really smart about it. Alongside all of that 3D-focused data, they included a lot of general conversational text.
Like cross-training.
Exactly. And to test it, they used a bunch of different benchmarks.
Okay.
These benchmarks test things like general knowledge, reasoning, even math problem-solving skills.
So like a language exam for AI?
Yeah, and guess what? LLaMA-Mesh passed with flying colors. Even after all that 3D training, it was just as good at language as before.
That's so impressive. So it gained all these new skills, but kept its old ones too.
Exactly. It's a perfect example of how powerful transfer learning can be and how well the researchers planned the training process.
So they were able to extend its abilities into 3D modeling, but didn't have to sacrifice any of its original strengths.
Right. That's the beauty of it.
So what kinds of language tests did they use? What were they like?
They used a bunch of well-established benchmarks for natural language processing.
Okay.
One was called MMLU. That stands for Measuring Massive Multitask Language Understanding.
Wow, that's a mouthful.
It's basically a huge quiz that covers all sorts of topics, from history and science to law.
Like a mega test.
Exactly. And then there's PIQA, which stands for Physical Interaction Question Answering.
Okay.
And this one tested how well the AI understands how things work in the real world, like if you drop a glass on a hard floor.
So common sense.
Exactly. And then there was HelloSwag, which challenged the AI to complete sentences in a way that makes sense.
That sounds hard.
It is. And lastly, they used GSM-8K, Grade School Math 8K. That one gave the AI word problems to solve.
So they made sure it didn't forget its elementary school math.
Exactly. And by testing LLaMA-Mesh on all these benchmarks, the researchers got a really good idea of its language capabilities, and they found that it kept its skills even with all the 3D training.
So it's this versatile tool that can really bridge the gap between language and 3D design.
And that opens up so many possibilities for human-computer collaboration and creativity.
This research is really pushing the limits.
It really is. And we're really just at the beginning with LLaMA-Mesh. The researchers are already looking at how to improve it, make it even better.
That's exciting. I can't wait to see what they come up with. But before we get ahead of ourselves, let's talk about those limitations that we mentioned before.
Yeah,
Understanding the challenges is really important.
absolutely. Let's take a closer look at those hurdles and see what LLaMA-Mesh needs to overcome.
All right, so we've talked about all the amazing things that LLaMA-Mesh can do, but let's be real. Every groundbreaking technology has its limitations, right?
Oh, for sure. And the researchers were very open about the challenges they faced.
Okay, good. So what's the first hurdle that LLaMA-Mesh needs to overcome?
Well, you remember that whole thing about quantizing the vertex coordinates? Yeah, well, it's great for efficiency, but it means we lose some detail in those 3D models.
So it's like compressing an image. You save space, but it might not be as sharp.
Exactly, and sometimes that lack of detail can be a problem, especially for things like architecture or engineering, where you really need precision.
Great. So if I'm an architect designing a building or an engineer working on a machine, LLaMA-Mesh might not be detailed enough yet.
Yeah, that's a good point.
Yeah.
But it's important to remember that this technology is still very new.
Right?
The researchers are already trying to improve that quantization process.
To keep more of the detail.
Yeah, without making things too complicated for the LLM.
Makes sense. So it's not a dead end, it's just a challenge to solve.
Exactly.
What other limitations are they working on?
Well, another big one is the LLM's context length.
Uh-huh, that working memory limit.
Right, exactly. And right now, that limits how complex and how big the models can get.
Okay, so I can't describe my dream house in perfect detail and have it build it for me?
Not yet.
All right.
But don't worry, things are moving really fast in the world of LLMs.
Yeah.
They're coming up with new ways to train them and make them better.
So those context lengths are getting longer.
Exactly, so maybe someday.
Fingers crossed.
We also talked about how the researchers saw a little dip in the model's language abilities after fine-tuning it for 3D generation.
Right. It had to specialize.
It seems like all that focus on 3D data might have caused it to lose a little bit of its general language knowledge.
Like it had to trade some of those skills to become a 3D expert.
Right, and the researchers are looking into ways to balance that out, maybe by mixing in more general language data during training.
So it's like a well-rounded education.
Exactly.
I like that.
And we should also remember that the training data itself has limitations.
Okay.
They mostly use the Objaverse dataset, which is huge, but it might not include every possible 3D object or design.
So is there a chance that LLaMA-Mesh might not know what to do if it comes across something totally new, something it hasn't seen before?
Yeah, it's definitely possible, but AI is always learning.
Right.
As we get bigger and better 3D datasets, LLaMA-Mesh can keep learning and improving.
So giving it more experiences to make it a better 3D modeler.
Exactly.
Even with these limitations, this is still a huge accomplishment.
Absolutely.
It's a big step forward in connecting language and 3D design.
For sure.
And it opens up all these exciting possibilities for collaboration and creativity.
It really is amazing to see what AI can do.
It really shows how much potential AI has to change the way we design and create things, and even how we interact with the world around us.
I couldn't agree more. It's like we're peeking into the future.
This has been an amazing deep dive. We've learned so much about how LLaMA-Mesh works, its incredible potential, and even the challenges that lie ahead.
It's been fascinating.
And to all our listeners out there, we encourage you to stay curious, keep exploring these new discoveries, and never stop asking questions.
Because who knows what the future holds.
And on that note, that wraps up another deep dive into the world of cutting-edge research.
It's been a pleasure.
Until next time, keep those minds hungry for knowledge.